Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So I'm going to talk about graphs of basic trig functions today. So I will talk about basically the general shape of a sine graph or a cosine graph or a tangent graph. And I will just briefly state the key features of each of this graph. Then after that, I'm going to move on in the next video. We're going to solve how to find missing angles, how to find solve questions relating to sine, cosine, and tan. All right, so before I proceed, don't forget to like, share, and subscribe. And if you have any question, please let me know. And don't forget that it's very important you click the notification bell so that when I post new videos, you'll be the first person to know. So today, I'm going to start with the sine graph. Now, the sine graph is similar to the saw. Remember, we talked about in the previous video, SOHCAHTOA, okay, where we talk about opposites over hypotenuse in a right angle triangle, right? But we're going to talk about the sine graph now and how does the sine graph function look like? Now, the sine graph is usually when we talk about the graph of a sine function when we have y is equal to sine theta, and it looks like a wave. So it's like a wave when you draw this kind of graph. So I'm going to write it down. So the graph of a sine function y is equal to sine theta. Okay. So this looks like a wave. So I'll show it now. So I've shown below. So I'm going to show you how the wave look like. So I'm going to try to draw this now. So let's see. See if I can get we have nope, get this out. So we have something like this. Okay. Have another one going like this. Okay. So what makes this interesting is the maximum number you can get here is going to be 1. So for every sine graph, the maximum you can get is 1. Then the minimum you can get is -1. So you get between 1 and -1. And each measure, so you can measure it either in degrees or in radian. So we can say, let's say this is 90 degrees. This is 180 degrees. This is 270 degrees. This is 360 degrees. And you can keep on going. Or you can also make it this also in the negative axis. This is -90. This is -180. This is -270. And this is -360. So this is one revolution in the positive and one revolution in the negative, right? Now, but what is interesting about the sine graph is that the sine graph starts from 0. Okay? The sine graph starts from 0. So this is 0. 90 is going to be 1. 180 is going to be 0. 270 is going to be -1. And 360 is going to be 0. The same thing. So you can see that we are having a kind of like a sigmoidal curve here or a wave here. Now the same thing, we'll keep on going with the wave. -90 is going to be -1. 180 is going to be 0. 270 is going to be 1. 360 is going to -360 is going to be 0. So you see, you go again. And you will see that we have a sigmoidal graph as well. See, it looks like a wave. So you see how a wave goes like this. And apparently this can go to infinity, all right? So in this part, I'm just going between minus 360 and 360, okay? And this is in degrees. Now, also, you can also do this in radians. So in the previous video, I showed you how to convert between degrees and radians. So we can also draw this graph as well in radians. It will give you the same thing. So if you do it the same thing. Now, but in this case now, we're going to convert this to radians. So 90 degrees is pi over 2. So the same thing, the maximum number you can get here is 1. And the minimum number you can get is -1. So for a sine graph, the maximum number you can get is 1. The minimum number you can get is -1. So the same thing, we have to now start converting. So 90 degrees, the same thing. This is going to be pi over 2. So pi over 2. 180 degrees, this is going to give you pi. 270 is going to be 3 over 2 pi. 360 is going to give us 2 pi. So exactly the same thing, but now we are converting from degrees to pi. So please, if you've not watched my video where I talked about how to convert degrees to radian and radian back to degree, this is a good place to go back and have a look at it. So the same thing, I can do the same thing here. So it's going to give me minus pi over 2. Okay. So it's going to give me minus pi. Okay. Then this is going to give me minus 3 over 2 pi. And this is going to give me minus 2 pi. Exactly the same thing. Now, what we're going to do is that we're going to draw this. So same thing, you start from 0. So that is the difference. So for sine, you start from 0. Then pi over 2 is going to give you 1. Pi is going to be 180. 3 over 2 pi is going to give you -1. And 2 pi is going to give you 0. Minus 2 pi is going to give you -1. Minus pi is going to give you 0. Minus 3 over 2 pi is going to give you 1. And minus 2 pi is going to give you what? 0. Okay? Same thing. You draw it as well. You touch all the points. And you will see that, yep, exactly like that. All right, so this is it in radians now, okay? So if while we start solving questions and you're asked to draw the graph, the sine graph in radians, this is how you're gonna draw it. So you can keep on going till infinity. Does that make sense? So you keep on going to infinity and stuff like that. But here I'm just stopping at from minus 360 to 360. So you keep on going all the way. It's going to become a wave and you keep on going like that, okay? Now, so quickly, I'm going to write down the key features of a sine graph. So now, for the sine graph, I told you it looks like this. It looks like a wave. And you can also go to the textbook. You can see they can also do it up to several revolutions, okay? And from 0 to 360 is 1 revolution, okay? And you see that it repeats after every 360. So if you notice this, from this point to this point, it's 1 revolution. So you can see this is 1. It repeats again. It's going to repeat again. So basically what I'm saying is going to repeat and keep on repeating till infinity. So, right. So now the next part now is that I'm going to write down the key features of a sine graph. Okay, so because I'm aware some of you do take notes, I'm going to write down the key features. So the key features of the sine graph. Okay, so the first thing, the sine graph repeats every 2 pi radian or 360. So that means one revolution is 360. So when it gets to this point, it's going to, for instance, in this case, it's going to repeat again. So you're going to get another form of repeats like this. Then when it gets there, you're going to get another form of repeats and all the way. So that means every 2 pi or every 360, this graph is going to repeat itself. So the graph repeats. So the graph repeats every 2 pi radian. Or 360 degrees. Okay. Number two, then what you also notice as well is that from this point here, you saw that the minimum number we have for sine is -1. So no matter what you press in your calculator for a sine of a particular number, the minimum you can ever get is -1, and the maximum you can ever get is 1. So that means we can now write that as one of the key features as well, that the minimum value of sine is -1. Okay. And also, number three, the maximum value is 1. Okay, so the maximum value of sine is 1. So you can see the minimum value we had here was -1, and the maximum value you have is what? Is 1. Now, another thing again you will notice for the sine graph is that the sine graph crosses the origin or passes through the origin. Are you seeing it? So it passes through the origin at this point here. You notice both for the degrees or the radian, you will notice that it passes through the origin here. All right. So, and after it passes through the origin, then after every 180 degrees, so that means here, the next time it passes through the origin again, was at 180. The next time it passes through the origin is plus another 180. So that means if you keep on adding 180 or subtracting 180, you will see that the sine graph will pass through the origin. So every 180 degrees turn is what? It crosses through the x-axis, right? The same thing, it passes through the x-axis every pi. So you have pi here, you have 2 pi, and the rest of it, you keep on adding pi, and you notice that it always passes through what? The x-axis. The same thing, when you subtract pi, the same thing, it also passes through pi as well. So that means it crosses the x-axis at 0, right? And every pi radian or 180 degrees before and after that. So you notice that every pi or 180 is going to cross the x-axis. So these features that I'm saying here are just basically from the graph that I've written up there. So number 4, the graph crosses. So the x-axis at 0. So that means at the origin. So some textbook, we call it the origin. So it crosses the x-axis at 0. And every pi radian or 180 degrees. Okay? So every pi radian 180 degrees before and after that. Okay, so you notice here that the graph crosses the x-axis at the origin and every pi radian or 180 degrees before and after that. Now, number 5 as well is that you notice as well that the sine functions reaches its maximum value at pi over 2 radian or 90 degrees. So you will notice that the maximum value is going to get is 1. So it's pi over 2. And every 360 or 2 pi radian after that. So if you look at this, so what we are saying here is that for this particular graph, that the maximum value is always at 90 degrees. And from 90 degrees, you keep on adding 360 to that. Or it's at pi over 2, and you keep on adding what? 2 pi radian to that. So that's what I'm trying to say here. So number 5, the sine function So the sine function reaches its maximum value at pi over 2 radian. Okay, on 90 degrees. Okay, so if it's in radian, it's going to be pi over 2, or if it's in degrees, it's going to be 90 degrees. Then after that, then every revolution, so that means every 2 pi radian. Or 360 degrees before and after that. Okay, then the final thing is that you will also notice that the sine function will similarly reaches its minimum value at 3 over 2 pi radian or 270 degrees, and every 2 pi radian or 360 degrees after that. So you see the minimum value now is always at 3 over 2 pi, okay, or 270 degrees. So if you have it in degrees, you'll see it as 270. So the minimum value is at 270 degrees. Then you keep on adding 360, or you keep on subtracting 360 to that value to give you the next value. So for instance, when you subtract 360 from 270, you will see that the answer is minus 90. When you subtract 2 pi from 3 over 2 pi, you'll see that the answer is minus pi over 2. So you keep on adding 360, and you keep on subtracting 360, is going to give you the value of the minimum value for the sine graph, okay? So that'll be number 6. Okay, number 6, the sine function reaches its minimum value at 3 over 2 pi radian or 270 degrees, okay? And every 2 over 2 on every 2 pi radian or 360 before and after that. All right, so the sine function reaches its minimum value at 3 over 2 pi radian or 270 degrees every 2 pi radian or 360 degrees after that. So this is the this is the key features of a sine graph, okay? So a graph of a sine function, y is equal to sine theta, looks like a wave, okay? So it looks like a wave, and the wave shown below. So I said for this, you can draw it in degrees or you can draw it in radians, okay? And also in the features, we have about 6 features. It repeats every 2 pi radian or 360. The minimum value you will get is -1. The maximum value you get is 1. The graph crosses the x-axis at 0, okay, or the origin, and every pi radian or 180-degree radian before and after that. And we talked about the maximum value and the minimum value as well. So now let's go to the next one. So we've talked about sine, we'll talk about cosine now. All right, so let's talk about cosine. So B, the next one is the cosine graph. So the cosine graph. Now, the cosine graph is a graph of a cosine function of y is equal to cos theta. So the last time we talked about was the sine function, that was the y is equal to sine theta. And also, it looks like a wave similarly as well to the sine graph, except that this wave is a little bit different, okay? So I'll talk about both of them now. So the graph, for the graph of a cosine, so the graph of a cosine function, okay? Y is equal to what? Cos theta, right? So, we're looking at the cosine function now. So it's y equals to cos theta. Now, but here it looks exactly like the sine graph. Okay, that means they're having the same wave pattern. Now, except that in this case, instead of it starting from 0, it's going to start from 1. Okay, and similarly, it can be said to be shifting by pi over 2 radian as well, but instead of starting from 0, it's starting from 1. Okay, so you have the same what do you call it? It have the same wave-like pattern. Okay, it has the same wave-like pattern, and also, but the only difference that instead of it to start from 0, like what we had here, that it was starting from 0, the origin, okay, but it's going to be starting from 1 instead. So it looks exactly. So when I said exactly, I'm referring to the same wave pattern. Okay, like the sine graph. Except, so now there's a caveat here. So except the graph starts from 1 instead of what? Instead of 0. Okay, so that's the major difference, except start from 1 instead of 0. Or some textbook can decide to say it's like a sine graph, but it's said to shift to the left by pi over 2 radian or 90 degrees. Okay, or can be said to shift to the left by pi over 2 radian or 90 degrees. Okay, so you can either start from 1, all right? Or you can say it's like a sine graph that just shifts to the left by what? 90 degrees. Now let me see if I can draw this again to show you. So what I'm saying is this is what we have here, okay? And this is what we have here, all right? Now, let's assume that I have, so normally if it was a sine graph, like I said, we start from if it was a sine graph, to be like this, starting from starting from the origin, okay? It would be like this. It was a sine graph, right? Like this to infinity, then like this to infinity. Good. Now, but what we are now saying is that a cosine graph, instead of starting from the origin, is going to start from 1. So it's going to come like this, same sigmoidal graph, but the only difference here is that it's not starting from the origin, it's starting from 1. So what I was trying to say as well is that you can also say that this is a sine graph that was shifted by 90 degrees. So if you look at this, I'll be able to do this here. So let's assume we have this, sorry. We have this. So we have this, something like this. All right, so now let's say we shift this now. So you shift this, so you can see it now look like a cosine graph. So it's like you shifted the graph by 90 degrees. And it's now very similar to the cosine graph that I told you that starts from what? Starts from 1. So you can see it now looks like a cosine graph. So if you look at it, you can now say, oh, okay, this is like a sine graph, but it's shift to the left by pi/2 radian. All right, so let's draw this a little bit better now. So we have this. So similarly, the highest number you can get for this is 1, and the lowest number you can get is -1, okay? So the same thing, we're going to have here to be 90 degrees. Here is going to be 180. Here is going to be 270. Here is going to be 360. So you can keep going until infinity, 450, and the rest of it. But I'm going to stop between 360 and -360. Same thing here. So here is going to be -90. Here will be -180. Here is going to be -270, and here will be -360. So like I said, instead of you starting from 0, you're going to start from 1. So that means the first one you have this one here. Then you keep going. 90 is going to be 0. Then you have 180 is going to be here. Then you have 270, and you have what? 360. The same thing is going to starting from 0. You're going to have -90. You're going to have -180. You're going to have 270, and you have what? 360. Okay. So the same thing, you now join this point, you now see the sigmoidal graph like this, like that, and all the way to the end. Okay. So this is when it's in degrees. So you can also repeat the same thing for when it's in radian, okay? So we can also repeat the same thing when it's in radian. So you can have something like this. So in radians, the same thing. You can have this to be this black pen, so it to be consistent. So this is going to be 90. This is going to give you 180. This is going to give you 270. Oh, so this is in radian. So I need to change it to radian. So 90 degrees in radian, that's going to give me pi over 2. Okay, this is going to give me pi over 2. Then 180 is pi. 270 is going to be 3 over 2 pi. And 360 is going to be 2 pi. Same thing. It's going to give us minus pi over 2. This is going to give us minus pi. Then minus 270 is going to give us minus 3 over 2 pi. And this is going to give us what? Minus 2 pi. All right. So the maximum number you get here is 1. And the minimum number you can get here is minus 1. Or let me take it a bit higher so that put it here. So then put the maximum number here, somewhere here, 1, okay? And the minimum number you get is minus 1, okay? So the same thing, like I said, in this case here, is that you then start from 1 instead. So you start from 1 instead of starting from 0. So you put it there. So the next one will be pi over 2. The next one is going to be pi, 3 over 2, and then to give you what? 360. The same thing, it's going to give us minus pi over 2, minus pi, 3 over 2, and minus 2 pi. So same thing, you draw the way down to this point, that way, all the way down here to this point, and that way. So this is drawing the graph in radians. Okay, so this is it in radians. So it's similar to the sine graph. It has a waveform, so you can keep on going like this all the way to infinity. Okay, but here the difference is that it's starting from 1 instead of starting from 0. Okay, so we're going to talk about the key features now of a cosine graph. So let's talk about the key features now. So the key features of a cosine graph. Right, so the key features. Okay, the key feature of a cosine graph. So now the first thing you will notice as well is that similar to the sine graph, it repeats every 360 degrees. So you will notice that it repeats every 360. So every 360 degrees is still the same shape of the curve you will get. So, or if it's in radian, it's going to be every 2 pi radian. So similarly, so number 1, the graph repeats every 2 pi radian or 360 degrees. All right. Now, also, what you will notice is similar to the sine graph, the minimum number you have will be minus 1, and the maximum number you can have in a cosine graph is going to be 1. So the minimum value of cosine is minus 1. And number 3, the maximum value for cosine is 1. Okay, so you see that for both, no matter if it's in degree or radians, the minimum value we get is 1, and the maximum value we're getting is -1. All right. So similarly, it crosses the x-axis, but now in sine, we're told if you go to sine, it crosses the x-axis every pi radian. Are you seeing it? Every pi radian, it crosses every pi radian or 180 degrees. So if you look at it crosses every pi or 180 degrees, all right, or 180 degrees. But in a cosine graph, it's a little bit different. It crosses here every pi over 2, okay? Every pi over 2 or 90 degrees. So it crosses it at 90 degrees and at pi over 2. Then when it crosses at this point, then you keep on adding 180 to each of the values. So that means it crosses at pi over 2 or 90 degrees and every pi radian or 180 degrees before and after that. So when you get this, when you add 180 to 90, it's going to give you 270. When you subtract 180 from 90, it's going to give you -90. Then you keep on subtracting to get all the points it crosses the x-axis, or you keep on adding 180 to get all the points it crosses the what? X-axis in the positive direction. The same thing, it crosses the x-axis at pi over 2. Then you keep on adding pi. So if you add pi to pi over 2, it's going to give you 3 over 2 pi. So that means it crosses the x-axis at 3 over 2. Then you keep on adding pi to each of these numbers. It's going to give you where it crosses the x-axis in the positive x direction. Or you can subtract pi from this, and it's going to give you minus pi over 2. And you keep on subtracting pi, it's going to give you where it crosses the x-axis in the negative x direction as well. Okay. So we can write that down as I think that should be the fourth one. So number 4, the graph crosses the x-axis at pi over 2 radian or 90 degrees, and every pi over 2, or and every pi radian, or 180 degrees before and after that. So the graph crosses the x-axis at pi over 2 radians or 90 degrees, and every pi radian or 180 degrees before and after that. So after that, number 5, okay. Now you can see that here it reaches the maximum value at 0, okay. So 0 then, and every 2 pi or 360 degrees after that, okay? And it reaches the minimum value at what? 180 or pi, or an every 2 pi and 360 degrees after that. So if you look at the graph we have here, the maximum value we have is at what? It's at 0. So the maximum value for cosine is at 0, then you keep on adding 360 or 2 pi to that to get the next maximum value. So if this is 0, the next, if you add 2 pi, 0 plus 2 pi, the maximum value is 2 pi, and you keep on adding again. Next one should be at 4 pi and the rest of it. The same thing here, the maximum value is 1. When you add 360 to 0, it's going to give you 360. The next one should be at 720 and the rest of it. The same thing that happens to the minimum value at 180 degrees, and you keep on adding 360 or 2 pi after that. Then the same thing here as well. So that means that will be the next point here. So number 5, the cosine function reaches its maximum value at 0. Okay, so the maximum value reaches at 0, then and every 2 pi so every 2 pi radians or 360 degrees before and after that. Now, similarly, like I said, it reaches its minimum value. So the cosine function reaches its minimum value okay, at pi radian or 180 degrees, and the same thing, and every 2 pi radian or 360 degrees before and after that. Okay, so the cosine function reaches its minimum value at pi radian or 180 degrees, and every 2 pi radian or 360 before and after that. So that is that for cosine. All right, so the cosine graph when y is equal to cos theta, it looks like that. So generally what you need to keep in mind is that it starts from 1 instead of 0, like in sine. But you can also say that this is a kind of sine graph, but have been shifted to the left by pi over 2 radian or 90 degrees. Okay. So what we'll do now is that let's go straight to the next one. Let's go to the last one for this video, which is I think the tangent graph. So we're going to talk about the tangent. We talked about the sine. We talked about the cosine. Now we'll talk about the tangent graph. So see the tangent graph. Okay. Now the tangent graph. So the graph of a tangent function, we have y is equal to tan theta similarly. Now, but this kind of graph looks a bit different from the cosine and sine graph, because this kind of graph is not a wave, but it's kind of a discontinuous function with asymptote. So this is not the regular sine wave or stuff we'll be talking about in the last few minutes. But in this case, it's more of like a discontinuous function with asymptotes, okay? So because I'm aware most of you do write, so I'm gonna write this down. So the graph of a tangent function okay, y is equal to tan theta, all right? So that means here we're looking at a function of y equal to tan theta. So however, it looks a bit different. than the cosine and sine. Okay? So it looks a bit different than the cosine and sine function. So, but it's it's different because here it is not a wave, but a discontinuous function. So it is not a wave. So you're not gonna get like a wave shape here, okay? But rather a discontinuous function. With asymptotes. So it has asymptotes. So if you've not watched my videos where I talked about asymptotes, this is going to be a very good place for you to go back and have a look. I talked about the horizontal asymptotes and the vertical asymptotes, okay? So now let's go back. Right, so let's see if we can draw the graph for this. So we have this one. We have this one here. Now, the interesting thing about this, one of the first thing you will notice is that there is no maximum or minimum number here. So that one makes it a little bit interesting. So there's no like, oh, this is the maximum, this is the minimum. No, we don't have this here. So so if it's in degrees, so this is going to be 90 degrees, okay? This is going to be 180 degrees. This is going to give us 270 degrees. And this is going to give you what? 360 degrees. And also for that, it's going to give us minus 90 degrees. This will give us minus 180 degrees. This will give us minus 270 degrees. And that will give us minus 360 degrees. Now, one of the things you will first notice is that they have a kind of a vertical asymptote at particular angle from 90 degrees and every 180 degrees after that. So what we are saying is that 90 degrees, you can have an answer. So it's like a vertical asymptote at 90 degrees. You're going to have every 180 after that. So if you add 180 to 90, you give you that. So you see that we know value, there'll be asymptotes at this point. So the same thing, there's going to be asymptote as well at minus 90. Okay. There's going to be asymptotes as well at minus 270. Good. Now, and also, another thing as well is that this graph also passes through the origin. Those are the two things you need to just have drawn before you start drawing. And from this, it's easy peasy. So you're going to go all the way to this, passes through the origin, comes close, but it's not going to touch it. Facing it like this. The same thing. You're going to start again like this. So it's going to pass at this point. You're going to pass at 180. It's going to pass at 360. It's going to pass the origin at minus 180. You're going to pass the origin at minus 360. So the same thing. You take it all the way up. Close here. But not touch it. Same thing all the way up. Pass that. So that's how the graph looks like. It goes all the way like this. And the same thing, it goes all that like this. And keep going. So you keep going like that. So you're gonna have like a discontinuous function with asymptotes as well. So as usual, this in degrees. Okay. So we can also draw this as well in radians. So it's going to be exactly the same thing in radians, but this time we're going to have it, instead of having it in degrees, we're going to have it in radians. So 90 degrees as well is going to be, change this to black. So 90 degrees is pi over 2, right? 180 here is pi. 270 is 3 over 2 pi. 360 is going to give you what? 2 pi. In the negative direction, it's going to give you minus pi over 2 minus 90. 180 is going to give you minus pi. 270 is going to give you minus 3 over 2 pi. And 360 is going to give us minus 2 pi. So similarly, there is no highest number, or there's no maximum, or there's no minimum, okay? So in this case then, we'll then draw the asymptote location as well. So like I told you, the asymptote location is always at, in this case, 90. So it's going to be, in this case here, it's going to be pi over 2. So it's going to be at this point here, at pi over 2. Then after 180 degrees after that, so you're going to add 180 to this. So it's going to give you a 3 over 2 pi. The same thing. You're going to also pass at minus 1 over 2. That's the next asymptote. It's going to be at minus pi over 2 pi, or minus 1 over 2 pi. Then you add 180 or 2 pi to this. It's going to give you at minus 3 over 2 pi. So like I said, it's also going to pass through the origin. And after it passes through the origin, every 180 degrees after that. So you add 180 degrees, add pi to this, then add pi to that. It's going to give us 2 pi. The next one will be 3 pi, 4 pi, and the rest of it. Then 0 minus pi, if you're going to the negative direction, is going to be minus pi. Then you have minus 2 pi. So the same thing is going to come all the way close, but not going to touch. Passes through this and goes here. Goes all the way, passes through this. So it's like a discontinuous function. So like this, passes through that. So the same thing is going to go all the way close, passes through, but will not touch. So it's coming all the way up. So passes through, but will not touch. And that's for that. So this is when you have it in radians. Okay. So in this case, you have it in degrees, while in this case, you have it in radians. All right. So now let's go to talk about the key functions of this graph now, the key features. So let's talk about the key features of a tangent graph. Okay, let's talk about the key features. Now, similarly, you'll see the graph always repeat every pi, if you notice. So every pi, it repeats every pi or every 180 degrees. So you can see that the graph repeats every 180 degrees. So the first one was, it passes at 0. Next time it passes was 180. Next time it passes was 360. Same thing, 0, pi, 2 pi. So you can see it repeats every pi radian or 180 degrees. So the graph repeats every pi radian or 180 degrees, okay? Number 2, there is no minimum value. Number 3, because you can see that there is no minimum value, unlike sine and cosine, where we talked about that the minimum value is -1 and the maximum value is 1. Okay, but here there is no minimum value. Number 3, as well, there is no maximum value. So there's no maximum value for tan. So also the graph crosses the x-axis at 0. So you notice that it crosses here at 0 in both the radian or the degrees. It crosses at 0. Now, after crossing it, then it now every pi after that. So the next one was pi, it crosses, you add pi to pi, or if you're going in negative direction, 0, minus pi, minus 2 pi. So like that, the same way. So if you look at this, same thing for the degrees, 0. Next one was what? 180. You add 180 again, 360. You keep on adding 180 that same way. So the next thing, the next rule, number 4, was that the graph crosses the x-axis at 0 degrees. So if it's 0 degrees and or 0 degrees or 0 radian, it does not matter, but it crosses at 0. That making sense? And every pi radian okay, or 180 degrees before and after that. Okay, so the graph crosses the x-axis at 0 and every pi radian or 180 degrees before and after that. Then when you're done, the next one, number 5, is that you also notice that it has asymptotes. So this has vertical asymptotes. So we talked about this in my previous videos. These are where the functions is undefined. Okay, so in my previous videos, I talked about how to find horizontal asymptotes and vertical asymptotes. So you notice that it has it at 90 degrees and every 180 degrees after that. Okay. So that's what you notice as well. So number 5, you notice that the tangent graph have asymptotes. Unlike the sine and cosine, there were no asymptotes, okay? So now the tangent graph has asymptotes. So asymptotes, these are values where the function is undefined. All right, so which are values where the function is undefined. So the tangent graph have asymptotes, and these are values where the function is undefined. And if you've not reviewed my video on vertical and horizontal asymptotes, this is a good point for you to go back and see how to do that. But for this, you just don't need, we're not calculating asymptotes here. So if you don't need to go back, it's fine. You can just proceed. But just in case, it's a good way to just remind yourself on how to find both the vertical and horizontal asymptote. In this case, we just have vertical asymptote here. Now, and also the vertical asymptote here is at every 90 degrees and 180 degrees after that, or pi 2 radians and every pi radian after and before that. So this asymptote, so that's number 6. So these asymptotes are at pi over 2 radians or 90 degrees. So you can have it at pi over 2. So you can see the asymptotes here. So we have it here at pi over 2. Or you can have it here at 90 degrees. So you can see it, you have it here at 90 degrees. Then every 180 degrees after or before that. Or you can, if you have it in radians, it will be every pi radians before and after that. So, and every pi radians or 180 degrees before and after that. Good. And that's all the key features about a tangent graph, okay? So the graph repeats every pi radian. There's no minimum value, no maximum value. It crosses the x-axis at 0 and every pi radian or 180 degrees before and after that. The tangent graph have asymptotes, which are values where the function is undefined, and the asymptotes are at pi over 2 radians or 90 degrees and every pi radians or 180 degrees before and after that. All right. That is that for tangent graph. So in this video, I just gave the key features, how the graph look like for the sine, cosine, and tangent. So now the next video, I'm going to talk about how do we solve trigonometric equations. So it's very important that you subscribe and click notification bell so that when I post the next video, you'll be the first person to know. So I'm going to see you in the next video where we talk about how do we solve trigonometric equations.